Permutations, this is a word you actually want to write down for your notes. Permutations. What's happening is it's telling you how many ways you can order n objects. So how many ways can you order objects? How many ways can they happen? And one of the big things that you need to remember is that order matters. Okay, it really, really matters what order you put things in. So if you're asking yourself, does order matter here, and you say yes, then you definitely want to be doing a permutation. Now yesterday, or in the last video, we talked about factorials. So factorials, remember n factorial or 5 factorial means 5 times 4 times 3 times 2 times 1. Those are also permutations. Order matters there. And what's happening is you have some objects and you're going to use them all up. For example, if you're looking at your book, we're looking at page 703. And we're talking about example 3. And what it says is that there's 12 skiers. And these are competing for in the final round of the Olympic freestyle skiing aerial competition. It says A, and how many different ways can these skiers finish the competition? And so as you're trying to answer that, you're saying, well, there's 12 skiers, and we're talking about all of them finishing, so we've got 12 places. And then you're saying, well, none of them have finished yet. There's a possibility of 12 different people in the first spot. Now once that person finishes, now you have 11 left. Then 10, and then 9, and we work all our way down. And we have to multiply all this together. Now I would never probably do this on a calculator without my wonderful factorial button. And so remember, this is really just 12 factorial. So you can plug that in our calculator. It'll give you some really nice and big number, like 479,001,600. Okay, now, part B, though, is a little bit different. Part B says, in how many ways can 3 of the skiers finish first, second, and third? So we only care about 3 spots. We don't really care about the rest of those losers, just the first 3 spots. And so as we look at this, we start from the very beginning, 12. We can start with 12 of them, and then 11 left, and then 10 left. And after that, I really don't care about the rest of them. So I just want 12 times 11 times 10. And when we multiply those together, we only have 1,320 ways that those 3 can finish. So it dwindles quite a bit there. This is also a permutation. It's just not a true factorial because unlike the other factorial, where it goes from 12 all the way down to 1, this one only goes from 12 down to 10. It cuts it short. And so it's no longer a factorial. It's just a permutation. So let's look at another example. So you have a homework assignment from 5 different classes to complete this weekend. Very likely story for you because they know you guys and your homework finishing abilities. So you have homework from 5 different classes. How many different ways can you complete the assignments? Well, there you're talking about completing them all. So we're going to say that there's 5 times 4 times 3 times 2 times 1, right? Because you have 5 to choose from when you start. When you're done with that one, now you only have 4 to choose from, and so on. And so you multiply those together and you get 120 ways that you can do all 5 subjects. Okay, B, and how many different ways can you choose 2 of the assignments to complete, first and last? So I did this, I know I did as a student. What do I want to finish first and what do I want to finish last? Well, in the first spot you have 5 to choose from, and in the last spot now you have 4 to choose from, and then the other ones are in between. And so there are 20 ways to do this. Okay, next example. You have 8 movies you would like to see, and how many ways can you see all 8 movies? So we're using them all up here. So we have 1, 2, 3, 4, 5, 6, 7, 8. You can choose the first one. You have 8 to choose from. Once you've watched that one, now you have 7 to choose from. And then 6, 5, 4, 3, 2, and 1. Okay, so you multiply all of those together, and you get 40,320 ways to watch those movies. But the second question says, in how many ways can you choose a movie to see this Saturday and 1 to see this Sunday? So there's only 2 that you need to pick. So you have 8 to choose from the first one and only 7 to choose from the second one. So there are 56 ways to do that. Remember, in all of these, the order mattered. What order we did this stuff in mattered. So now let's talk about the formula. So a permutation has a formula besides just putting down the lines that we had. Okay, a permutation looks as such. first off notation. You might remember this from ninth grade, but we have NPR. So N is the number of choices, and R is the number of events, so the number that we're actually using. And once you know those numbers, then you can plug them in this formula where you go n factorial on the top over, and then you have a little math to do, because what you're going to do is you're going to figure out what's n minus r. And whatever that is, you're going to use factorial on that. Okay, so there's your formula. You should write that down in your notes if you haven't yet. Okay, and if I turn to page 704, we have example 4. And so here it says, you are considering 10 different colleges. Before you decide to apply to colleges you want to visit, some or all of them. And how many orders can you visit 6 of the colleges? So remember, you're starting with 10 colleges. So we're going to have a 10 there. And then you're only choosing 6 of them. So we're wondering how many ways you can attend or look at 6 of them. So on top we're going to have 10 factorial, because on the formula it says n factorial, n is that number there. And then on bottom we have to take n minus r. So we take 10 minus 6, and we'll factorial that. So we have 10 factorial over 10 minus 6 is 4 factorial. So then if I want to figure that out, I can go ahead and write it out. This is the fun part where we're going to write them all down. Over 4 factorial. And so what happens is the 4's cancel the 3's, 2's and 1's all cancel. So it's just 10 times 9 times 8 times 7 times 6 times 5, which gives us 151, 200. Okay? And then in the very second part of this, it talks about how many ways can you visit 10 of the colleges. And so, if I'm visiting all 10 of them, then I have 10 permute 10. So I have 10 factorial on top, and on bottom I have 10 minus 10 factorial on bottom. So that means I have 10 factorial on top over 0 factorial. And so you might be saying, well, I know what 10 factorial is. But I don't know what 0 factorial is. And here it is. 0 factorial is just 1. And so ultimately, if you have the same number of events as you do choices, this is really just the same thing as 10 factorial. Because if you look, it's just 10 times 9 times 8 times 7. Nothing really cancels here with the 1. I mean, the 1's cancel kind of, but not really. All right, let's move on. All right. I missed the bottom here. Okay. So here's something really important. NPR works for all objects that are distinct. So it's really important. The word distinct, if you don't know what that means, distinct means that they're different. So if I look here at the letters for dog, I have D, O, and G. I have 3 different letters. And so if I'm going to place 3 letters down, I have 3 spots. In my first spot I could put 3 letters. I have 3 choices. In my second spot I have 2 left, and then my third spot I have 1 left. So there's 6 ways I can put the letters D, O, G. Let's see them. So we have D, O, G. I have D, G, O. Then I have O, D, G and O, G, D. And then we have G, D, O and G, O, D. So there's all 6 ways that I can put those letters D, O, G. But what about for the letters for mom? Now if I look at that, I can go M-O-M, M-M-O, O-M-M. But there's nothing else I can do, because I can't tell the difference between one M and the other M. So if I were to switch those two, it doesn't matter, it'd be the same thing. And so I really only have 3 ways to do this. And so what happens is, if I don't have distinct letters like this, then I have fewer ways of ordering them. I have fewer ways. And so we have a way of doing that without actually having to order them all yourself. And so here's what you do. So it says the number of distinguishable permutations of n objects where one object is repeated Q1 times another is so on is, well, here's what it is. You're still going to do your factorial. Okay, so if you remember up here with DOG, this was really 3 factorial. Okay, you're still going to do that. For MOM, it's really just 3 factorial on top. But what I'm going to do is I'm going to divide by the number of times my indistinct thing happens. For example, M happens 2 times. So I'm going to divide by 2 factorial. So if I look at this, this is 3 times 2 times 1, and on bottom I have 2 times 1. Cancel out the 2 and the 1, I am left with 3. So how many ways can I order the letters MOM? I can order them 3 times. Okay, so let's continue the next page and look at some more examples. So let's say I want to order Mississippi. I have lots of repetition there. So first off, I need to know how many letters I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters. So if I didn't have any repeating, I would just say, you know what, this is going to be 11 factorial. But the fact is I do have repeating letters. So I have an I, 1, 2, 3, 4. I have 4 I's, so I'm going to do 4 factorial. I also have S's. I have 2 there and 2 there. So I have 4 S's, so I'm going to do 4 factorial there. And then, on top of that, I have 2 P's. So I'll be doing a 2 factorial on bottom. That's a lot of factorials. But now let's check that out. So I have 11 factorial. And then on bottom, I'm going to have 4 factorial. And then I have another 4 factorial. And then I have a 2 factorial. So now we start crossing things out, like the 2's and the 1's. Let's see, I can go 4 and 3 and 3 and 3. I can go, let's see here, 4 and 2 make 8. What do I have left? I have a 3 and a 2 makes 6. So then, the ones on bottom don't really matter. I just multiply what's left. So I take 11 times 9 times 10 times 7 and then times 5. And we should get 34,650. Okay, let's try a little bit of a simpler one. I guess we went in the opposite order as usual. So here I have the word Ohio. Now typically I'm going to want to go 4 factorial. Except you'll notice that I have 2 O's, so I'm going to go 2 factorial on bottom because I can't tell those apart. So we have 4 times 3 times 2 times 1 over 2 times 1. 2's cancel, 1's cancel. There are going to be 12 ways to order Ohio.